In our next video, we're going to look at mutually exclusive and independent events. So, events which have no outcomes in common are called mutually exclusive events. So, for mutually exclusive events, the probability of A or B is equal to the probability of A plus the probability of B. So, in other words, we're talking about pairs of events which can't happen at the same time. So, for example, if I'm rolling a dice, I can't roll an even number and roll a 3 at the same time on one dice, since 3 isn't even. So, mutually exclusive events can be represented in a Venn diagram by regions which do not overlap. So, a simple Venn diagram here, we've got region A and region B, and they do not have any intersection there. Another type of events we have is something called a pair of independent events. So when one event has no effect on another, they are called independent events. And this means that the probability of B happening is the same whether or not A happens. So if I'm rolling 2 dice, the scores on those dice are independent of one another because the score I get when I roll 1 dice isn't affected by the score on the other dice. And for independent events, we've got that the probability of A and B, so the probability of 2 events both occurring, is equal to the probability of A multiplied by the probability of B. So just looking at a couple of examples here then. So our first example, we're told that events A and B are mutually exclusive, and the probability of A is 0.2 and the probability of B is 0.4. So before we look at any of the questions, I just want us to consider the idea of mutually exclusive events and our ability to represent those in a Venn diagram with no intersection. So if I just draw our 2 events, A and B, and we would have that A was equal to 0.2 and B was equal to 0.4. Now, in that Venn diagram, our probabilities would have to add up to a whole one. So if I've got 0.2 and 0.4, they add up to 0.6, which must mean I've got 0.4 on the outside as well, because now all of these will add to make 1. So the probability of A or B. Now that was part of our definition for mutually exclusive events. We said that if events are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. So that's the probability of A plus the probability of B. Now the probability of A was 0.2. Probability of B was 0.4. So that's just going to equal 0.6, and that's going to be our answer for part A. For part B, we're being asked for the probability of A but not B. So the probability that something is in A and not in B. Now, since there's no intersection here, everything that is in A is not in B. So A but not B is simply going to be that 0.2. So our answer to that second question is just going to be 0.2. For part C, neither A nor B, so that's everything on the outside, and since we've drawn that as a Venn diagram, it's clear for us to see that that's just going to be equal to 0.4, because that's not in A nor is it in B. Our second example. So events C and D are independent. The probability of C is 1/3 and the probability of D is 1/5. And we're being asked to find the probability of C and D. So our rule for events which were independent is that the probability of those 2 events both happening is equal to the probability of one multiplied by the probability of the other. So the probability of C and D is equal to the probability of C multiplied by the probability of D. Well, the probability of C was 1/3. The probability of D was 1/5. And when I multiply those together, that is going to give me 1/15. So our answer there is just going to be 1/15. Our final example, we're told that the Venn diagram shows the number of students in a particular class who watch any of 3 TV programs. So we've got A, B, and C as the 3 programs, and then some values within our Venn diagram there. So we're being asked to find the probability that a student chosen at random watches B or C or both. So first of all, we need to find how many students there were in total. So our probability is going to involve that total. So 3 plus 4 is 7, plus 5 gives us 12, and 10 is 22, plus 7 is 29, plus 1 is 30. So our probability is going to be out of 30. And now watching B or C or both, that is all of the people accounted for in these circles here. So 4 plus 5 plus 10 plus 7 gives us 26. So that is going to be 26/30. For part B, we're being asked to determine whether watching A and watching B are statistically independent. Now, for those to be independent, the rule we said was that for independent events, they are independent if the probability of A and B is equal to the probability of A multiplied by the probability of B. So we can test whether that is true. So the probability of A and B, well, that comes from the intersection on our Venn diagram, because the number of people who watched A and B is 4 out of that 30. So the probability of A and B is equal to 4/30. The probability of A times the probability of B, well, the probability of A is this 3 and this 4, so that is 7 out of 30, multiplied by the probability of B, 4, 5 and 10. 4 and 5 is 9, plus 10 is 19, so that's 19 out of 30. So 7/30 multiplied by 19/30. When we multiply those together, we can use our calculator for that. That's going to give us 133/300. So the probability of A and B was 4/30. The probability of A times the probability of B was 133/300. Now, rather, 30 times 30 would give us 900. So that's going to be 133/900. So these two are not the same. So since they are not the same, since 4/30 is not equal to 133/900, the events are not independent. And that is our answer to that question. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.